Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. How to read piping and instrumentation diagram. In this video course, you will learn what is P&ID, why is it important, how it is useful to chemical and process engineers, what are the symbols, abbreviations, codes and tags used for developing the P&ID, and how to read P&ID. Please subscribe to the channel. By subscribing, you will motivate us to produce more knowledgeable video content for you. Please subscribe now before you forget. For the process engineers, production engineers, and operators, piping and instrumentation diagram is one of the important engineering documents to gain knowledge and understanding of the piping system, the instrumentation and control systems, emergency shutdown, and trip interlocks provided in the process. This is one drawing that every chemical engineer or petrochemical engineer or petroleum engineers will use throughout the life cycle of the plant. It is suffice to say, you cannot function without this document. The piping and instrumentation diagrams, P&IDs, provide additional information needed for overall design process. These additional detailed information are essential to begin construction of the plant. The P&ID is developed based on the process flow diagram. It includes every mechanical aspect of the plant. The information provided in the PFD is excluded from the P&ID. So what does a P&ID contain? The piping and instrumentation diagram contains schematic for the piping, valves, and components of instrumentation system such as indicative instruments, control valves, emergency shutdown valves, etc. It also contains engineering data related to piping. How is P&ID useful to chemical engineers in their different job roles? P&ID is used by chemical engineers in all the three phases of the development of process plant. They are design phase, construction phase, and operational phase. In the design phase, the process engineers use the P&IDs to design and develop layout of the process systems, component specification, development of control system, hazard and operability study known as HAZOP. During the construction phase of the project, process and operation engineers use the P&ID to monitor the progress of construction of any section of the plant with respect to installation of piping and fittings and instruments. In the operation phase, P&IDs are used as a document for training of engineers and operators prior to commissioning and startup of the plants, retraining of new employees during the running phase of the plant, maintenance and modification of any part or section of the plant during the life of the plant. Learning by tracing the lines in the field using the P&ID is an important part of the training for those who are required to assume career role as process engineers, operation engineers, and plant operators in the manufacturing plant. Needless to say, P&ID is the most used process engineering document for process and operation engineers during the life of the plant in operation. Any changes made to process at any point of time should get updated in the P&IDs, and the revised version must be available for ready reference. Shown in this figure is a P&ID of an oil-fired process heater used for heating a process fluid going to a reactor. How will you read and understand this P&ID? First, you should know what is the equipment and how it is represented in the drawing. Next, you should know the various streams entering and leaving the equipment, what process fluid the pipe is carrying, and how it is represented in the P&ID, what is the size of the pipe, what is the material of construction and insulation of the material used, what is the fuel used for heating, what is the size of the fuel line, what is the material of construction and insulation for the fuel line, type of valves used for isolation, types of instruments, control valves and symbols. P&ID of a process heater provides all this data on a single sheet, and you should know how to read these data. Shown in this figure is the P&ID of a distillation column and its associated system. This has several equipment with interconnected piping network carrying process streams and utilities. This is more a complex system than the process heater you are seeing above. How do you read this diagram? P&IDs are developed with symbols, abbreviations, and numbering systems. To learn how to read the P&ID, you should understand the following first: line service identification, pipeline identification, insulation and equipment identification, drawing identification, piping symbols, process equipment symbols, instrument symbols, and identification. Symbols for line service identification. Line service includes process fluids, special service liquids, utility services such as steam, air, nitrogen, condensate, etc. Process fluids are identified by the symbol P. Special service liquids include acids and caustic. The symbol Al is used for acid and Cl for caustic. Steam and condensate system are identified by the symbols presented below. Hc, high pressure condensate, Mc, medium pressure condensate, Lc, low pressure condensate, Hs, high pressure steam, Ms, medium pressure steam, Ls, low pressure steam. Air and gas service are identified by the symbols presented below. IA, instrument air, PA, plant air, LP, low pressure nitrogen, FG, fuel gas. Water used in the plant is identified by symbols presented below. BFW, boiler feed water, CWS, cooling water supply, CWR, cooling water return, DMW, demineralized water, FW, fire water, PW, process water, DW, drinking water, WW, waste water. Refrigeration systems are identified by the following symbols: AR, ammonia refrigerant, FR, freon refrigerant, PR, propylene refrigerant. Drain systems are identified by the following symbols: CD for chemical drain, HT, closed hydrocarbon drain, NT, non-contaminated drain, ST, sanitary drain, WD, closed water drain. Fuels, oils and vent systems are identified by the following symbols: FO, fuel oil, LO lubricating oil, SO seal oil, AV atmospheric vent, SV safety valve to atmosphere. Symbols for equipment identification. A process plant uses large number of process equipment and special equipment such as reactors, distillation columns, heat exchangers, pumps, compressors, etc. in the production process. Each process equipment is identified by a symbol. You will learn in this section some of the commonly used equipment symbols. Shown in this figure are symbols for tray column and packed column, the commonly used separation equipment. Also the symbols for centrifugal pumps, gear pump, screw pump, reciprocating pump. Shown in this figure are symbols for centrifugal compressors, screw compressors, and heaters and coolers. Also for cyclone separator and material handling equipment like rotary feeder. This figure presents the symbols for horizontal storage vessels, receiver tank, oil-fired heater, and vertical agitated vessel. Here you find the symbols for rotary dryers, crystallizers, single effect evaporator, and a plate and frame filter. Here you find the symbols for storage tank with floating roof and dome type roof, vessel mounted on load cell, and kettle type reboiler. Here you find the symbols for ejectors, bucket elevators, rotary compressor, and tower with integral reboiler. This figure presents the symbols for belt conveyor, electric motor, spherical storage tank, and heat exchanger. Pipeline identification. Usually, a large process plant has several individual units, all integrated in a sequential way to perform the production process. The units could be a raw material processing section, a reactor section, separation section, product purification section, and raw material and product storage section. A multi-product plant will have several such plants within a single site, comprising 20 to 50 units depending on the number of products. For example, a small plant may consist of 5 units as shown below, each unit performing a process function and numbered as unit 100, 200, 300, 400 and unit 500. P&IDs for such plant is prepared individual unit wise. Let us consider, for instance, a fluid flowing through a pipeline connected to a distillation column in a process plant. This line is identified by the description as follows: 4-inch -P -1 -40 -001 -A1A -H. The identification label indicates the following. The first number indicates the size of the pipeline, 4 inches. The second number indicates the service for which the pipeline is used. In this case, P is for the process fluid. The third number indicates the unit number of the plant, in this case, the unit 1. The fourth number indicates the area number of the unit, in this case, area 40. The fifth number indicates the pipeline number in the unit, in this case 001. The sixth number indicates the piping specification related to the fluid and the service condition, in this case A1A. The seventh number indicates the classification of the insulation used on the pipeline. In this case, it is H. Of these, the most important engineering data one can understand from the P&ID are the line size, the line service, the piping material, and the insulation. Piping identification. Piping is identified by the term in the pipeline identification label A1A. The first letter indicates the flange rating. The second numerical number indicates piping material. The third letter indicates additional pipe information. Equipment identification and equipment codes. Typically, the equipments are identified by the label shown. The equipment identification description has 5 separate terms, each being a letter or a number or a combination of both, representing a specific meaning as illustrated in this sketch. The first number is a unit number. The second term represents the equipment code. The third number is the area number. The fourth number is the sequence number. The fifth term represents multiple equipment, such as spare equipment. This table presents the codes for commonly used equipment. P for pumps, K for fans, compressors and blowers, H for heater, B for boiler, C for towers and columns, E heat exchanger, CT cooling tower, T for tanks, A for agitator, stroke mixer, FD for filters. Insulation identification. Insulation material is identified by a letter as shown in the table. Given are some of the commonly used insulation material. N is used when there is no insulation on the pipeline. H denotes normal heat conservation. F represents full heat conservation. P stands for personal protection, that is for safety of the personnel. R is used for refrigerated fluids, that is piping carrying cold fluids. Symbols for piping and piping components. Piping includes process piping, piping for other services. Pipe fittings and piping components include valves, filters, strainers, reducers, blinds, caps, etc. Shown here is a symbol for piping services and commonly used valves and valve components. Continuous dark lines represent the process and other services. The underground lines are represented by broken line with the letter B. Battery limit is identified by the dashed line as shown. The different types of valves such as gate valve, globe valve, etc. are identified by the respective symbols shown. Non-return valves, three-way valves and angle valves are identified by the respective symbols shown in this figure. Reducer, line blinds and caps are represented by the symbol shown here. Also shown in the figure is a symbol for identifying the drawing number continuity, which is an arrow. plant uses flexible hoses for various service points. The symbols for the hose joints are included in this figure. Steam trap and expansion bellows are identified by the symbols as shown. Process needs sampling points for collecting samples for quality control. These sampling points are identified by the symbols shown here. Instruments in the process and instrument flow diagram are identified by letters and symbols. The list includes measured variables, restriction orifice, ruptured disc, safety relief devices, push buttons, indicators and transmitters, limit switches, and control panels. Every instrument is identified with tags, which are letters along with numbers for identification. The commonly used instruments and the tags are shown in this table. For example, A for analyzer, F for flow rate, L for level, and so on. The pressure safety valve and pressure and vacuum relief valve are identified by the tags PSV and PVR. Many critical operating parameters are provided with alarm for sounding warning signals. They are identified by the letter H for high, HH for very high, L for low, and LL for very low. Instrument control valve is the final control element in the control loop. There are different types of control valves. Illustrated in this figure A are some of the commonly used control valves. The instrument generates and transmits as well as receive command and signals. The signals include pneumatic signals, electrical signals, hydraulic signal, and data link. The signals are represented and identified by appropriate symbols in the P&ID, as illustrated in the figure B. Various types of instruments are used for measuring, transmitting, and control purposes. Included in the list are orifice plates, Venturi tubes, pitot tubes, rotameters, turbine meters, and mass flow meters. Flow instruments are represented and identified by the symbols as illustrated in the figure A. The symbols for representing the safety valves and safety relief valves are illustrated in figure B. This figure illustrates the symbols used for identifying the instrument displays. Some instruments readings are displayed in the field, some are displayed in the local control panel, and some are displayed in the DCS panel. These different displays are represented by the symbols as shown. Also, there are several safety interlock for the process safety, and the interlock connections are identified by the diamond-shaped symbol as shown. Having learned how to identify the line service, equipment, and piping, as well as instrument symbols and components, let us now take a look at the P&ID of a stripper, where the symbols, tags, and abbreviations are used. The stripper is identified by the label C-100. 3 pipelines are shown in this figure. The feed to the tower is identified by 2-inch SW-A1A-N. The gas outlet line from the tower is identified by 4-inch P-A1A-T. Take a look at the steam inlet line, the pipe fittings, valves, and how it is connected to the tower. Can you identify the flow control valve on the steam line? Can you identify how the level indicator display on the DCS is represented? Spend some more time and understand the various symbols and representations in this P&ID. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.